Hello everyone, this is Wanmat Army and I am Muhammad Taqi Hassan, your maths mentor in this channel. And in the previous sessions, I have completed arithmetic progression topic from the chapter sequences and series. And now I am going to start geometric progression. So now let's head right into the session. Now, we already discussed that we have four types of progressions: arithmetic progression, geometric progression, harmonic progression, and arithmetic geometric progression. In that, we completed arithmetic progression. So now let's find some facts about geometric progression. I have making the videos smaller. They will last up to 20 minutes or a minute or two. Now let's head into the topic: geometric progression. Now this is a general way of expressing a geometric progression: ar square, ar cube, to the power of 4, ar to the power of 5, and so on, ar to the power of n minus 1. And here a is the first term and r is the common ratio. Now we have seen in arithmetic progression that the second term differs from the first term, say like a constant k, and the third term differs from the second term with the same constant k. So the third term minus the second term equals to the second term minus the first term. So the pattern in that is they all have a number increasing, so they get a number added or subtracted. But in geometric progression, a number is multiplied or divided. So this is another sequence progression. It's a sequence with a pattern. And here every time when we say that a sequence or a progression is in geometric progression, then every term should be multiplied or divided with some common constant k to get the next term. So here we have a and we multiply that with r to get the second term, which is ar, and we have to multiply the second term with the same number that we multiplied the first term with. So ar into r is again ar square, and so on. We get ar to the power of n minus 1. And here again a is the first term, r is the common ratio, and n is the number of terms. So the last term will be ar to the power of n minus 1, number of ar to the power of number of terms minus 1. These are the general formula. So first, the nth term, the formula for nth term. Nth term equals to a into r to the power of n minus 1. So here there are only n terms. That's why the nth term was the last term. So that's why I told you that ar to the power of n minus 1 is the last term. Now here, the nth term from the end of a finite GP consisting of m terms is ar to the power of m minus n. So, and geometric progressions also exist in infinite series. So infinite terms can also be present, and we will find about that in the future. Now, the nth term from an end of a GP with the last term L and common ratio R is L into L by R whole to the power of n minus 1. Now let's look at this point again. The nth term from the end of a finite GP. So you have a finite GP, you have n terms. No, you have m terms, and you are finding the nth term. So that will be AR to the power of m minus n. And now the nth term from the end of a GP with the last term L and common ratio R is L into L by R into whole to the power of n minus 1. Now what's the proof? If the first term was AR, then the formula would have been AR to the power of n for the nth term, because every time we keep multiplying with R. But the first term is A, so it will decrease, the power of the nth term will decrease by 1 r. So ar to the power of n divided by r is nothing but ar to the power of n minus 1. That is one of the exponential law. Now sum of the terms in a GP. So sum of n terms equals to a into r to the power of n minus 1 whole divided by r minus 1 when the common ratio is greater than 1. So the first term multiplied by common ratio whole to the power of number of terms minus 1 divided by common ratio minus 1. It can be also written as last term into common ratio minus first term divided by common ratio minus 1. and we got this formula over here, the including the last term from this here, because the last, if it has n terms, then the last term would be ar whole to the power ar to the power of n minus 1. So if I open this bracket, ar to the power of n is nothing but l into r. If I multiply l into r, it's nothing but I am multiplying r with this ar to the power of n minus 1. Then this would become ar to the power of n. So lr equals to ar to the power of n. lr equals to a into r to the power of n. So if I substitute that lr in here, I would get lr last term into the common ratio minus this first term divided by r minus 1. This is the formula for the sum of terms in a GP when the common ratio is greater than 1. So in this case, I've said that in a geometric progression, the pattern should vary with the multiplication or division. In arithmetic progression, subtraction or addition. But here is multiplication or division. If the value of r is greater than 1, it's nothing but multiplication. If it is less than 1, it is some sort of fraction and it is dividing. And if the value of r is 1, then you just get the same term every time. So if the first term is a, the nth term is a, and every term will be a because the common ratio is 1, right? Then the sum will be just na. Is that? Yeah, na. Now let's see the sum of n terms when r is less than 1 or when we are dividing. A into 1 minus r to the power of n divided by 1 minus r. So it's the same formula, but we have reversed these terms. We have multiplied this with minus 1 equals to, again we get this formula. We have to find that from this. It's not a big thing. Now sum of terms in an infinite GP. So you have infinite terms and the sum of them is, the sum is in an infinite GP is s infinity. We denote that as s infinity equals to a divided by 1 minus r when mod of r is less than 1. Why are we telling that mod of r is less than 1? Why? Think about it. Why it should be less than 1? Why it can't be greater than 1? R has to be less than 1. Mod r has to be less than 1. Now let's divide it into two cases. The first one is the common ratio can't be 0, right? You won't get a GP. You just get the first term and next you get zeros after that. So it shouldn't be 0. It's either it is either from 0 to negative 1. Let me just write that over here. Next, it's the value of r should be from either 0 to 1. So see, I am using open brackets here. So because 0 and 1 are not included, so r cannot be 0, it cannot be 1. It can be 0, but you won't get a GP. You will just get the sum of the infinite terms a as a. Let me show you how. So if the value of r is 0, then this will be a by 1, which is a, because all the terms will be 0 except the first term, which is a. Union, I am representing of the u. So union 0 comma 1. Sorry, this is a negative 1 here. This is a negative 1. Negative 1 comma 0. So this is, now first think of the positive thing, the one we know from the beginning. If r is greater than that, if r is greater than 1, then it will become a multiplying, it will be a multiplication type of GP, right? Because r, the second term will be greater than the first term, the third term will be greater than the second term. So obviously it's an infinite GP, so the numbers will keep growing on and on. So obviously the sum will be also infinite. But if they are decreasing, at one point they will come to a very negligible point. So if I take the first term as a and the common ratio as 1 by 2, which is less than 1. If I multiply that, I will get 1 by 2, which is 0.5. if I multiply it again, I will get 0.25, again 0.125, again I will keep getting smaller numbers, and at one point I will reach a negligible value like 0.000001 or something. So that's why the mod value of r should be less than 1. Now let's just erase this thing. So, and remember that L is the last term again. So now let's just see a problem on this. I have mentioned earlier that I'm going to try to keep the sessions short, up to 15 to 20 minutes. Now here's the question: if x, just a second. Okay, now if x, y, and z are the pth, qth, and rth terms respectively of an AP and also a GP. So this question is related to arithmetic progression and geometric progression, so you will have to refer the previous sessions too, and the links are in the description below. Then the question, then x to the power of y minus x into y to the power of z minus x into z to the power of x minus y is equal to, I will give you exactly 1 minute starting from now. You have 1 minute to solve this question. You can pause the video if you want extra time. Oh, sorry. Here's the question. Hmm. 25 seconds remain. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. And time's up. This is the solution over here. This thing. Just wait a second. So, first, it is. I have been told that x is the pth term in an AP. So I have written x as a plus p minus 1 into d, and a is the first term of our AP and d is the common difference. And again I have told that y and z are the pth and rth terms respectively. So I have written that in the same manner too. Now in the question, this is what we're trying to find, right? X into this whole thing, x to the power of y minus z into y to the power of z minus x into z to the power of x minus y. So first I'm going to find the values of y minus z comma z minus x comma x minus y. So we know this piece of information over here, x equals to this and y equals to this and z equals to this. So I'm going to find the value of x minus y. So x minus y, the a's get cancelled out, take d common, you will get p minus 1 minus q plus 1. And because I get plus 1 because minus into minus 1 is plus 1, and the plus 1 minus 1 cancel out, you are remained with p minus q into d. Similarly you get these three too, you get the other two, y minus z and z minus x. Now we also know the second piece of information, that x, y, z are the pth term in a GP2. X, y, z are the pth, qth and rth term in a GP respectively. So again x equals to small a into r to the power of p minus 1, and small a here is the first term in this GP, and I have to capital A here to avoid confusion. And I have written x as small a into r to the power of p minus 1, and y as a into r to the power of q minus 1, and z as a into r to the power of r minus 1. Now I know the value of x, y, z. I know the value of x minus y, y minus z, and z minus x. So I'm just going to substitute the values over here. So x to the, x, this is x to the power of y minus z. I have done that here, into y. The value of y is ar to the power of q minus 1, that I written here. that I wrote here, to the power of z minus 1. Another one, the last term is over here, the z one. Z is r to the power of r minus 1 into x minus y. I wrote that here. And if I am going to multiply this, we know that p minus 1 over here, we have to get all the terms into this x y z thing, right? Yes. So for that, I'm going to take the p minus 1 that p minus 1, wait a second, yeah, r to the power of p minus 1 is nothing but, I'm going to substitute the value that I got from here, guys. So if I substitute that over here, I will get a to the power of y minus z plus x minus y. So this is how I got this. So I have taken the power of a from every term and just added them. So that's another law of exponents, right? So I have taken common a from every power, a to the power of y minus z. So I am not replacing anything over here. A to the power of a to the power of y minus z plus z minus x plus x minus y. So I'm adding the powers of a over here and taking a away. So here this plus y and minus y will get cancelled out, minus z and positive z will get cancelled out, and x and negative x will cancel out. So a to the power of 0 into r. Now let's go to the r thing. Now r, this is another exponential law over here. A to the power of m whole to the power of n is a to the power of mn. Now here the powers of r is, and here two exponential laws come together. The first one is a to the power of m whole to the power of n equals to a to the power of mn. The other one is a to the power of m into a to the power of n equals to a to the power of m plus n. So after applying that, I get this thing, r to the power of, and this whole thing, we have to add these three binomial pairs over here. So this will be a quadratic equation. I'm not letting it become a quadratic equation, but we have to add these three terms, whole to the power of r. So the value of this will become 0. So a to the power of 0 is 1. So leave that a outside. Now we have to concentrate on this r thing over here. So r to the power of p minus 1 into q minus r. So I am converting this z y minus z into what I know, p minus q into d, small d. We have to take small d over here. Nothing will matter, not be such a big problem. And if I simplify this whole thing over here, I'm going to get 0. So let me just take an example. So here if I multiply this, I get minus qd, and again here I get positive qd. So that just was an example. And again I'm going to get the value of r whole to the power of this thing as 0. So r to the power of 0 is nothing but 1, and 1 into 1 is 1. I will give you a few time to calculate this. It will be 0 again anyways, and this is a d, this is a d. Now let's go to another question. Now find the sum of n terms of the series 6 plus 66 plus 666 plus and so on. This is not an arithmetic progression, because the difference of the first term and the second term is 60, whereas the difference of the third term and second term is 600. So that's not an arithmetic progression. But is it a geometric progression? It's not a geometric progression either, because 6 into 11 is 66, but 66 into 11 is not equal to 666. So let us see how we solve this question. But first I'm going to give you 1.5 minutes for this question. It may be tricky, so I will give you 1.5 minutes for this question, and your time starts now. You can pause the video for extra time. 30 seconds remain. Fifteen seconds. 10 seconds. 5 seconds. 2 seconds. And time's up. So this is how I solve this question. So first of all, this is not a geometric progression, so we have to remember that I have taken 6 common. So I will get the sum of n terms equals to 6 into 1 plus 11 plus triple 1 plus 4 ones plus and so on up to n terms. Now I am you need to know this strategy to solve many questions. So there are many questions like this type. Just add a bracket over here. Yep. No. I have multiplying and dividing by 9, so I will get 6 by 9 into, and this I have multiplied this into 9, remember. So 9 plus 99 plus 999 plus 9999 and so on. Now I'm just going to simplify the outside. 6 by 9 is nothing but 2 by 3, and again 9 can be written as 10 minus 1, and 99 can be written as 100 minus 1, and then 999 can be written as 1000 minus 1, and so on up to n terms. Now 2 by 3 into, I have taken this minus 1 outside, so only taking the tens. 10 plus this is 10 square plus this is 10 cube, and minus 1 up to n terms, so minus n. So now this is in geometric progression, right? 10 plus 10 square plus 10 cube plus 10 to the power of 4 is in geometric progression. The first term is 10 and the common ratio is also 10, and the number of terms is n. So we are going to find first of all the sum of this GP over here. So we already know the formula. This is the formula. R is greater than 1. It's a multiplication. So a into r to the power of n minus 1 by r minus 1. So that's what I substituted over here. A into 10 into r power n terms. R is 10 minus 1 by 10 minus 1, which is n. And don't forget that minus n that we got from these minus 1s over here. So this is what we're going to get after simplifying that. Now again multiplying 10 inside the bracket, I'm going to get 10 to the power of n plus 1 minus 10. And if we want to take this minus n into here, we have to multiply it and divide it by 9. So after multiplying it divided by 9, taking inside the bracket, I'm going to get minus 1. And we take that inside, and we get 10 to the power of n plus 1 minus 9 and minus 10 whole divided by 9. And I'm multiplying this 9, I'm multiplying the denominators and taking them out. So I'll get 2 by 27 into 10 to the power of n plus 1 minus 9 and minus 10. And that is our option B, I think. Yeah, option B is the right answer. Option B is the right answer. Option B is the right answer. Now, the sad thing is the homework question that I gave in the last session wasn't answered by either one of them. I don't know if it was too hard. It is a hard question. But again, I'm going to give this homework question for homework in this session also. And if next session nobody answers, then I will give the answer. Now, you can pause the video if you want to see the question one more time for extra time. The sum of the first 100 terms of an arithmetic progression is minus 1. If the sum of the even terms lying in the first 100 terms is 1, then which of the following statements is or are correct? Common difference of the arithmetic progression is minus 3 by 50. First term of the arithmetic progression is 149 by 50. 100th term of the arithmetic progression is 74 by 25. Now, till then, bye bye. I will meet you in the next session, and don't forget to subscribe to the channel and hit the like button if you liked it.